everybody. Yeah,
excuse me. Volume is too low. We cannot hear.
Can you hear me now? Is it better?
It's too low.
Can you hear me now? Anybody else that
It's
can
not
hear
clear
me,
for
please?
me. It's low.
I think you should increase the volume of your device because I guess some people can hear me. Yeah.
Okay, yeah. It's okay now. Sorry.
All right. So I'm good to go.
Yeah.
Welcome to week. Yeah, let me send the link to the slide. I don't know if the material sent the link to the slide, but then I'll send the link to the slide. So the messages, so you can check the messages to see the slides. Can you see my screen? Can you share my screen? Okay. My screen just slide. I see my screen. Anybody? All right, so that's what to do. Link to the slide in the chat section. Welcome to week 6 of GIDA Starknet Developer Bootcamp, and this week we're going to be learning how to test our contract and our Cairo programs. All right, and my name is Weval. For those of you at yeah. So in this, if you have any problem hearing me or seeing what I'm trying to display, just make a comment in that section. See is available to help you out. So in this session, in week 6, we're going to be discussing introduction to Starknet, to test in a Starknet, advanced testing techniques, and then having some practice and assignment. But for today, which is our first session, we're going to be doing a little introduction to testing of programs to Starknet. Why do we test? The basic tests, the basic unit tests that we're going to be writing together, and we're going to be writing a counter contract, testing a counter contract. I believe in the previous classes, we've been taught how to write Cairo programs and Cairo smart contracts. So this should not be a big issue for us, right? Can you just respond? So yeah, I see that. All right, good. So straight away, introduction to testing. Testing is can you see my screen? Yeah, okay, I can see your response. Because I want to do this on the slideshow. Is fair enough. So testing in software or in real life sense. Now let's break it down to real life, everyday life. When you talk about testing, you're trying to find out if something works the way you expect it to work, or if something is what you think it is. Right? If you don't understand, this is a simple explanation. Let me give you, for example, you buy a grinding machine, right? And you're told this grinding machine grinds cassava into powder, right? As a user or as a customer that patronizes and buys that grinder, you go ahead and you test that machine to ensure that that machine works the way it's expected to work, right? But then what you don't realize is that before that machine is given out or sold, even for commercial use. There is a lot of testing that has been done on it by the producers and the factories. They test it using their own machines to test the machine they produce, right? So that's basically the same ideology we're bringing into software, right? So when you write software, it's a very important concept to always test the software you're writing, right? And then you might think testing it um just involves okay, you should write a contract or a program that, for example, shares an airdrop to the whitelisted users. For example, you might think, okay, to test it, you have to like share a particular set of airdrops to the users, right? And then, but in the real sense, the testing can be done without all the real life cases, right? What I'm trying to explain is that we can replicate these real life use cases using software. So that's how we're going to do the testing. I don't know if you understand, but you understand much better what I'm trying to explain about testing software with software in the course of this course, all right, in the course of this bootcamp. So, yeah, we write our tests using the Cairo test program and Starknet Foundry, right? I'll be showing you that in a bit in my command line. You should be able to see my command line. Let me just clear this out. Yeah, I believe strongly you guys have been introduced to Scarb, the Cairo Package Manager, and Starknet Foundry. So I believe you have that installed on your system. If you have Scarb installed or Starknet Foundry installed, can you please signify? I want to be sure. Okay, that's nice. That's nice. So I believe you already have Scarb. You've worked with Scarb, creating a project, and yeah. So now we're going to be focusing mainly on testing, since we believe that we have Scarb and SF Foundry installed. So now SF Foundry is a tool, right? And in SF Foundry it comes with two tools, right? SF Foundry comes with two tools, the SNCast and the SM Forge. The SNCast can be used to deploy the deployment, declaring the contract of written, right, and creating um, accounts and all that, all from the command line. But also we have the SM Forge. I'm just going through most of these things that we have been taught before. So yeah, just to brush you up. And then we have the SM Forge, which is also a command line tool that we can use to test our smart contract, right? And now we're going to be using SM Forge to test our smart contract. Our Cairo test program. Okay, let me just show you this real quick. So in my command line, yeah, can you see my screen? Can you see my command line? Is it clear enough? So I have, you can easily check if you have Scarb installed by running command scarb dash dash version, and it returns the version of Scarb you have installed. I have it 2.10.1 installed on my Windows. I'm using a Windows machine right here. So yeah, I can clear that out. Any command you see or you don't know, you can't see on my screen, just ask in the comment section, raise your hand. I want to make sure I'm guiding you guys through every single step. Right. So now I created a folder, a directory called GIDA, right? So I can just seed into that directory. CD means to change the directory into the directory part. Directory part is GIDA, right? So who doesn't understand what I just did right now? Just still understand what I did by CD, by changing directory. So I believe everybody understands that too. So yeah, everybody understands that. So I'm in the GitHub directory. What I want to do next, I want to start a new project. All right. This is just to show you the difference between the Cairo test and the SN4. I'm not writing any code yet, so don't panic, relax. Right, so I still get to go back to our slide. So this just to show you. So if I do something like Scarb, new, running any tests, 3, right? Now you can see there is a prompt, right? It says which test runner do you want to set up? Starknet Foundry, which is default, and Cairo test. So these are the main test runners we use for testing Cairo program, right? But mainly the Starknet Foundry can be the test smart contract written in Cairo, right? Cairo test can be used to test all Cairo programs, right? Not necessarily the smart contract, right? So yeah, that's about that. I can just clear that out and go back to my slide. All right. So in session 1, which is the introduction to testing, I've gone through the introduction on testing, right? So the next thing I'm going to consider is why do we test? All right. So let me just talk about my slideshow. So why do we write tests? I chipped in a little bit of this when I was talking about testing, but then if the first reason why we write tests is to verify that the contract behaves as expected, right? So we write tests to ensure or to assert or to confirm that this contract or this program, whenever I run this program, it will always give the expected result. So, and the best thing with running a test is you can run the test for as many times as you want, right? Rather than testing it manually, you can run your test, your code to test as many times as you want, which ensures that you are producing same output for every single time you run the test for the specific test conditions that you set. All right. So yes, to ensure that the smart contract is as expected. All right. That's one of the first reasons we write this. And not just depend on smart contract. In any software, the main reason why I write this in anything, any product, any reason is to ensure that it works as expected. Right. Then the next reason why I write this is identify and resolve vulnerabilities. So vulnerabilities can come in form of bugs that simply makes the code unsecure. All right, makes the code unsecure. Or it gives a way to go, let me say, from the back door, right, into our code, making the code unsecure. Right, and just one important thing to note is that in terms of smart contract on blockchain, right, in most cases, in almost every case, right, but in most cases, because there's a term called upgradable smart contract here. In most cases, when you deploy a contract, you are unable to change that contract. That's the concept of immutability. All right, so it is very, very crucial to write tests and to find out what are the vulnerabilities, what are the things that can make this code unsecure. Because in the long run, people begin to use the smart contracts when they integrate it to their front end and other applications and whatnot. Right. So this contract that you write end up in hands of many users. Right. So you need to be sure that their data, their information, their assets are secure. That's why we write this to ensure that our contract, our program is not vulnerable, right? Because little as a simple vulnerability can cause a huge loss of so many assets and even tokens, all right, tokens like USDT, and I'm trying to talk about tokens revenue. And even in recent times, we've seen like so many cases where contracts was found vulnerable and a lot of money was stolen, like in the Bybit scenario that happened recently. But then that's one of the reasons why I write this. So another reason why I write that is to simulate real world use cases, right? To simulate what happens when you the gas is low when trying to execute the transaction. You can simulate those cases in our test. All right, our test, all right, you can simulate each of those cases. And one important thing I mentioned earlier is to prevent financial loss. Right. So write this to prevent financial loss because in most cases our smart contract interacts with real life assets. Right. So we need to make sure our smart contracts are secure. Like we always test our smart contracts. Right. I will see following. Give me a thumbs up. That's so good. Anybody? All right. So now we understand why we write our test, right? So up next we are going to be looking at the types of tests, right? Type of tests. There are three main types of tests in software as a whole. I think this is blocking data. Right? So yeah, there are three main types of tests that we are going to consider. And oh, I think there's an error on my slide. Error on my slide. I'm going to fix that very soon. But then, yeah, this is one of the reasons why we test, right? So this is a real life scenario. This is one of the reasons why I write tests, right? So yeah, my bad. But then this is one of the reasons why I write tests to make sure things work out as expected. You understand? So yeah, so the integration tests, okay, let me start with the unit test, then I'll change it. So for unit tests, right? Unit tests, it performs an isolated testing of individual functions or contract components, right? That's what we call unit testing, right? You pick a particular block of code or a particular function, right? So a function, maybe the function is a transfer function, and the particular what the function does, it transfers the ownership or a token from one user to another user. That is the only thing we're going to be testing. We're going to be testing that to ensure that that function transfers the ownership from the first user to the other user. That is the only thing that test is going to be test is going to be asserting, right? That is for the unit test. The unit test just test a particular function or a particular component. And in most cases, right, in most cases, when it comes to Cairo contract, our unit tests are written in the same file as the code that you're testing. For example, yeah, we'll see that when I write the code then. But then our unit tests are usually written in the same file where the function that you're trying to test is. Then for integration test, right, it's tests how the contract interacts with other contracts, right? Or let's say, yeah, interacts. I said it integrates with other contracts, but then interacts is fine. Interacts with other contracts, right? So that's how integration test works. Integration test works out the components, how the functions, how everything comes together to work together to ensure that it works properly. For example, the transfer function can be a part of a whole contract, right? Transfer function is a single function, right? So write unit test for the transfer function. Then integration test, write the integration test, integrate how the transfer function works on the part of the code, right? That's the integration test. Then for end-to-end tests, end-to-end test simulates real-world interaction from start to finish. So it tests every single part of the code from creating an account to getting ownership when you create an account to transferring the ownership, every single part of the application or the code or the contract. Make sure you test it end to end. All right. So I believe you understand what the different types of tests are, right? Reactions, everybody should understand the types of tests. Anybody has any question, any type of test? Nobody, no questions. All right, I'll be asking questions at the end of the class. So up next, I'm be diving into code editor, right?
Sorry. Excuse me,
Yes.
sir.
Yes.
Sorry. The last test that you talked about, end-to-end test. Can you just throw more light on it, please?
Right.
The
So
end-to-end test.
end to end, can you hear me?
I can hear you. I can hear you.
Okay, end to end test involves testing each part of the contract, like kind of like works together, right? The unit test, then the layered upon by the integration test, then end to end test, kind of like make sure that every single, um, for example, using like a simple um Web2 solution that maybe you can relate to, right? The end-to-end test makes sure that the backend works with the front end and each function is working, right? When a account is created, it's created in the backend, right? You understand? So it makes sure that every single thing, every button it displays, every single you should understand what I'm trying to paint for you right now.
Yes. I understand. I understand now.
So yeah, the end-to-end test makes sure that every single part of the code, the contract, every contract is interacting with, right, is tested, right?
Okay.
Is that okay?
Yes. In other words, the difference between the three kinds of tests is that for the first one, the unit test, it tests is a test of a single function or a component
Yeah,
inside a contract
exactly.
within a contract. It tests a single
Yeah,
function inside one contract. While the integration test, it tests different contracts to get like you can test it test between different contracts. Why the
yeah,
end to
yeah,
end the end to end is a test that's really like you said the real world interaction, like it tests the whole, like let's say
yeah. I
the
literally
whole.
just say what is in my slide, but then it's
Okay,
fine. It
so
shows that you are
that's how
seeing.
I understood what you
Yeah,
just
it's
said.
fine. And
That's
also, you
good.
can also go through the Cairo documentation, the official Cairo documentation on testing, because I believe your other instructors have referred you to like the Cairo documentation several times. So please make sure this is going to be like your best friend writing Cairo code. You always want to look at this thing. Oh, somebody's asking for my Twitter handle. I'm not saying it again. Here's my Twitter handle. And I dropped also a link to the official Cairo documentation. Right. And yeah, my CEO has dropped the link to the SFRB testing documentation. So yeah, I hope you guys are at your computers. I need you to spin up your idea right now. But before that, let's quickly go to our terminal. Right. I'm going to start doing this from our terminal. And I'm going to go back to the code that we've come to before, right? The command we've come to before. Yeah, this is where we are at right now. Basic unit test. Right. I'm going to write the basic unit test and test it. So I'll show you how the unit test works. Then we'll go to like a small test using this method. So we all know how Scarb works, right? I can use two commands to do this here. I can do the Scarb init, I can do the Scarb new, and then add a directory. Right. The main difference between those two commands is that if I'm using the Scarb init, I need to like be in the directory that I want to create a Scarb file or a package, right? A new contract or a new package. You understand? Let me explain it even better. Okay, so if I'm doing Scarb, I already created a test3 folder, right? So and there's the test4 and it shows me the options, right? Let me do that. So now we have I do ls, we have 4 tests, okay, 3 tests. That means I didn't create the test folder. If you have any questions, please ask. Right. Then so now we have our test4, and if we cd into the test4, cd into the test4, we have the files that Scarb has given us, right? That scaffolded this files. So yeah, as if I use the Scarb new, what do you call it? Scarb new command. Scarb new, then I add a directory. That's how it works that way. But then if I go back to my GIDA directory and I want to create a new folder or a new scaffolded package in the GIDA directory, I just do scarb init, right? And it's going to set this up in GIDA directory, which is the root directory, right? You understand the difference right now? Or if I want to go into a particular directory, if I want to create a directory together with the package in it already, then I just discard name and the name of the directory. But if I want to like create a directory separately, I'm just switching this to this loop somehow, and let me say test5. Right, so I made the directory test5, and then I can cd into test5. Right, there's nothing in test5, so I can just easily just calculate, and this is going to create a setup test for me in the directory. That's how easy it works. But then let's go to writing code. I'm sure you guys have bored already. So we're going to be naming this very funny name. So the first test we're going to write is a basic unit test. So you can write it just as a simple Cairo program, not as a smart contract. You can do that, but then I want us to write the first test, and we're going to test it using the Cairo test, right? I'm going to use Cairo test, then the other is going to test like with SN4. I'm trying to make sure conscious of our time here. So yeah, I'm gonna be using Scarb new and first test. That's what I'm gonna do. First test. So please make sure you're following along. You can name your folder, whatever, and you just press your up or down button to select what test runner you want to use. So I'm going to be using Cairo test for this. And okay, you can see there's an error. What's the error saying? It says use of uppercase letter has been disabled. And then you can see it be disallowed. We use of uppercase letters. So that tells us what we cannot use that name to create our folder. So first, things like this, right? And it's not work. So do this with Cairo test, and boom, we have our first test up. So our first test directory, and we can ls it, we can see it directly right there. So I have vscode installed, which has to the code ID installed. I also have cursor installed. So I'm probably going to use the cursor for this, but then if you do code, code is the function to use to use your Visual Studio Code. That's the command, and then the name of the directory, which is first directory. Right? This you can press tab to like complete that way. If you're having any questions, please make sure to simplify. And I'll be able to always check the chat. Let's make sure to simplify. So then I press enter and my ID will be open right now. Yeah. So now on my ID, this is cursor ID. And it's zoomed out like the mark, so you guys can see clearly. So that's how it looks like this. So yeah, this is what the Cairo test runner. When we open this, when we create a new package, this Scarb using Cairo test runner, scaffolds this program for us. It just gives us this spike. Thank you for using Cairo test. But then we're not going to be working with this today. Alright, I'm going to be working with this. So I'm going to change this to the test we're going to be doing. Can anybody hear me? Signify, I need thumbs up right now. Alright. So we're going to be writing our own test for this and our own program. So we're going to be using a simple calculator. To work with. So I've cleared out that, and I'm throwing errors function not found because I already deleted the functions. I'm still deleting the feed function, taking it out of everywhere. So yeah, I'll prepare the tone file. So basically, from what you've been taught, the main function in the Cairo program is like the entry point to the application, right? And I already deleted it. I got back. Alright, so now we have an entry point. So now what this block right here represents, this represents you can guess, a unit test. Why? The first reason why I think it's a unit test is I should return back everything that was there. You see, it basically tests one particular function. And what is the particular function? Field function. So this test, all it does is to make sure that the field function works. Assert that the field function works. But then we have to write our own text. I'm not here for field function. So the test we're going to be writing simple calculator functions, right? Addition, subtraction, multiplication, division, right? I believe somebody else can even write this for me. I don't have to write this myself. But then follow along. It's like this basic syntax for writing a function. But for addition function, we want to class variables x, which we can give an unsigned integer, this is for, and y, this is for. I believe everybody knows what's going on here. And we're going to be assigning a return type, right? So it's going to be this is for also. Right. So now we're going to write the code. So how are we going to do this? X plus y. That's right, this is our function. Our function. Because you understand how this works. X plus y. I did not put, if you notice one thing, I didn't put a, what do you call it, a semicolon at the end of it, right? Because if I put a semicolon, I have to explicitly mention that I want to return this, return whatever this is, right? So that's why I did not put a semicolon. So if I remove the semicolon and I remove the return statement here, it's just implicitly just returns. It just knows that, okay, we wanted to return this, right? But then if I didn't do that, I have to go through all the stress and tell them, okay, then return this. So now I'm writing the next function, simple functions. So which is going to be for subtraction. Somebody raise his hand. Who is?
Yeah, it was me, sorry. I wasn't quite following from when you started up vscode. Can you just paraphrase the whole thing that you've done?
He's trying to follow. But then, go again. So for those that were following, can anybody explain the basic of this function and what we've done here? We've not really done much. We just wrote one function. Can anybody explain? I should do it myself. I know some people that will be following, so I want me to call you. I would have to call you.
Okay, let me explain to him. Okay, so what we're doing here is that we're writing a small test to see the structure of testing. It is a Cairo program. It's not a smart contract. Okay,
Yes.
so this is why you have the main in there. Okay, so it's doing two functions, like the addition function. So add a plus b. Here it is x plus y, and it's going to do also a subtraction function. Subtract x from y or y from x or whatever. And then I guess from here we're going to write the tests to be able to test those two functions. That's what I understood.
Thank you so much. Thank you so much, Lami. I will say let everybody give me a round of applause for them. That's fine. Thank you. So I believe David, you are clear on that. So let's proceed with this quickly. Same thing, same one. This is for and then x minus y. Then for this function multiply x is for y. I need something. So all this is listening for me.
I'm sorry. Can I? Hello.
Yeah.
Sorry. I'm an observation. I want to like in the subtraction function. I want to just ask or say something. Why don't you do a check or that we do an if statement or an assert just in case if we get a negative value so that the build up doesn't panic. For instance now for instance y might be bigger than x and if
I
you,
understand what you're trying to say.
so I don't know if you can.
We can do that, but then I'm trying to make this as
Simple as okay.
As possible, so we can test it with all of that.
Sure.
But then you can also go ahead and do that. I'll send it to me. I'd love to see that.
Okay.
So now we have our basic functions out here, right? You can't tell me what next. Everybody knows what we're doing next. So what are we going to do next? I don't write in our case, right?
Yes, but are you not going to include them in the main function first?
Exactly. So somebody in the chat, write it out, or anybody with their ID open. I want to see you do that. As if I expect everybody following, right? I want to see somebody do that quickly. Are you guys following? Everybody's no. Something listen.
Sir, I'm just trying to write it now.
You're not following all this far.
I was
Everybody else.
following you. I was following what you're doing, but I was not writing.
Okay, so can you share your screen?
1 second. I'm coming.
All right.
But if anybody is ready,
I
that
don't know.
person
Should we wait for hours? Yeah,
I think you should just go on. I'm here.
I should go on.
Yes, please.
Next time, please follow us so we can do that.
Yes.
Sorry, what did you
Oh,
ask?
I was
Prince,
asking someone to write the um, main function to include the functions we've written in the main function. I know my screen, I light just went out to be put back on really quickly. So bear with me. So, okay. Can you see my screen? Can anybody see my screen? So I'm writing the test already. I just want to proceed to writing the test, which will be so much easier for us. So use super. You can see if you have the Cairo 1 extension installed. I think you should do that. So have the Cairo 1 extension installed to bring out all these things so easily for you. So yeah, Cairo 1.0 extension. If you have that installed, you should do that for you. So use super. So what super does, like, exposes the functions in the parent creates or the parent of the package. So you use super add, and then you can just use a curly bracket and then get all the functions at once. If I've done it this way, use super add. Can you see me? Can everybody see me? That's the back to you. So I don't know if anybody was with me when I was doing this. I thought that's the arbitrariness. So I was basically adding these functions, right, to the test. So what the super does, right, it exposes the functions in the parent of, or it exposes the function in the parent module. Right, this mod test, right, creates a module. So the test becomes a module of its own. But then, and the file is a module of its own. So the super, what super does exposes the functions that all these are public functions that I would say exposes these functions to this test module. So I can basically do this, use super add, use super these, and so on. So getting all the fancy import first, which is the parent directory. So a simpler way to do this is just to use equal brackets and add as many functions you want to add from the correct module. Multiply. So I think these are just the functions we have. Correct module, right? So I know some people are saying this syntax of CFP, right? Passing this CFG test, right? So what this basically does, this meta, right? What this does, this is just telling the compiler, Cairo compiler, that every single thing, this module that is following this tag here is a test, and it should be run when test is running, right? So like one of these code will be run when you are calling any of these functions or when you are accessing the main function. It's only going to be run when you are running Scarb test, right? So you are running Cairo test runner, right? I hope that's clear. Like this configuration just basically tells it to run this only when you are running the test runner, right? And this hashtag hash in the brackets and test tells us that whatever function is coming after this is a test function, right? This attribute, this meta attribute is telling us that whatever function that's coming after this is test. You understand? Is anybody following? I should show that. All right. So the first question, right? I think writing our test as functions, right? So you're writing functions to test functions. This was what I was explaining about using software to test software. So first function I'm going to write is test add function, right? So I'm going to be testing add function. It's basically a unique test. Why? Just testing a particular function to assert that is out there. So now when we are testing smart contracts, we always want an expected result, right? So we use this function called assert function, right? The assert function is written, but then you always want to assert that a particular value, right? It gives a particular result. So this is how the assert function works. Takes a value and takes a result. This is not the syntax, but this is the logic. So you can get the value, you can get the value from a variable, you can explicitly write the value and then write what you expect of it. All right. And also the assert function. Now when we write the original syntax of the assert function, there's an assert macro that we use, right? It's usually from this once Scarb package or once scaffold the or you come to the assert macro. Right? That's how you add this exclamation mark behind it. Right? The macro that allows us to be able to use not just fields, but also I believe you guys know what fields factory is, right? And byte arrays are, because I'm mentioning all these things and Scarb.tomo, all these things. Right. So yeah, the assert macro basically works like this. So for the test add function, now we have the add function in this module, right? So you can use anywhere in this module, then we call the function, right? And how it works, right? Let's say 5 or 3, comma, according to the syntax of the function, right? X, Y. So our first X variable is 3 and the Y is 7. So if a mathematics student is supposed to give an output of what? Output of the correct result. Plus, everybody's speaking. Everybody's speaking. 3 plus 7 is supposed to give us 10. Come on. But then, since you guys are not following, so the way the Assert works again. So our function now is going to return a boolean, and if the boolean is correct, right, it is going to just assert it and move on. But if not, there's an error message that we can pass, right? This error message now is what's going to be outputted, or it's what's going to be as the output when we run this test. So for example, now we're running the add function, right? It's going to give us a value of 10, right? So 10 is meant to be equal to 10. This is an equality comparator, right? And 10 is supposed to be equal to 10. And if not, you can now give an error message, right? If not, you can now give an error message that adds or add 3 or 7 or add not equal. What I'm trying to do, I'm trying to get like the shortest error message. I think it's blocking it. Error message I start coming up with this. Not to call 10. Right? So now look at past where I think we can put one single quote, right? Remember that. I'll put single quotes. Writing here 252. But now, if we're using the Assert macro, you can use double quotes. That is double quotes for our error message. So that's like the case add function. I know it kind of like supposed the time to write this first function. But then that's what it helps us to write the other functions very quickly. I think everybody understands how to this function. Something out, right? Okay, everybody understands this function. So there are also other assert functions that we can use. We can use assert LT, right? Now, what is going to do? Going to make sure that the values LT means lesser than, right? GT greater than, right? This basic assert works just to ensure that a boolean value of true is correct and then returns the error. Assert L3 takes the parameters and make sure that each right. I'm saying too much instead of just writing it. Add 10, comma, right? This is add 10, comma 5. What is supposed to give us? Anybody following?
15.
15, right? So, yeah. And if it's not 15, results is not right. So this is like the error message. So these are Assert L2 works. right? Okay, you guys did not get the part of the lesson that I was expecting somebody to ask me a question. The lesson that how do you not take it? The lesson that is supposed to
Yeah.
assert this first value, right? For example, if you take out this function and just write the value 5. Yeah, somebody mentioned something.
Yes, I wanted to ask a question. I wanted to ask why you did it that way.
Why?
The first one, when you were doing the add, right, you used the equal sign. So
Yeah,
yes, but for the second one, you wrote it, you did not use the equal sign.
and that's what I'm trying to explain to you, that for this assert macro, all it does is to confirm that a Boolean value is returned, right? That is the true or false, right? So we are going to run the whichever check we want to run, right? And make sure that check returns the Boolean value of true or false. And if not, it's going to return an error, right? But for the assert LT, where the assert LT works, it's going to take a first parameter, which is the first value, right? If you add 10, 5, it's supposed to give us what? 15, right? And then it's going to take another value, right? But in this case, we're given the same 15, which should not be, right? Do you understand? So let me make this 16 because that our test was going to fail. So I'm making this 16. So it's taking the first set of values, 10 and 5, which is going to give us 15, right?
Yeah.
Then that's the question. You did.
I'm
Then
here.
give us 15. And it's taking the other value, 16, right?
Okay.
So it's going to assert that 15 is less than what? 16.
16.
So it's taking the first value and second value. And we're going to assert that the first value is less than second value. Or else it will return the error. This is clear now.
Yes, yes. It is. Thank you.
Yeah. So there's also a assert EQ. Assert EQ. What this does, instead of taking a boolean also, it just takes a first value and second value. Let me write the function. Add 10, 5, and 15. Right? Okay, this is the result is not less than 16, right? Because this is supposed to after that less than. So if it's failing, the error should be the result is not less than 16. But then all these are tests are going to pass. But this is for the add function. I'm just going to copy different asserts. You understand? Different asserts macros are out there. You can use assert data than and so
Hello.
and go.
Hello.
Yeah, I can hear you.
Hello.
Someone trying to speak. I can hear you clearly.
Okay. Sorry. While you were explaining the test function or the test app, my network was giving me issue, so I had to log out and log in back, and your screen was blank. I couldn't see what was going on. So can you just explain the assert, like these three assert I'm seeing, the assert and assert it and assert EQ, like what's going on in this check here?
Okay, can you see my screen now?
I can see your screen now. I can see your screen.
All right. So what we're going to do, I'm not going to go through this function again, right? We're going to go to the next test. We're going to test another function. and use the same assert, right?
Okay.
It's going to explain the same things. So now we're going to be writing a new test, right? So what this means, this is just saying, okay, we're writing a test, and the name, this macro here, right, is telling the compiler that this is a test. So we're writing this test, and then we can try to write another test. We have to put this one small test. Then it's a function named test. What are we testing this time? So, right, testing the subtraction function. And yeah, a subtraction function is not so complex, right? Just subtract two things. But then someone mentioned something about compilation error, right? So we're going to test it. So the first test assert so now when we are writing tests, we always want to test the positive, right, and the negative scenarios, right? So now we're testing, if you observe something about the test you're writing, we're writing this test knowing that these tests are going to pass, right? But we are still writing those tests, knowing fully well that these tests are going to pass. So in the event that these tests fail, we know something is wrong with our code, right? And also we're going to write tests that we know that are going to fail. So in the event that these tests pass, we also know that something is wrong with our code. You understand what I just explained right now? So we're going to do that, but I have to explain using this sub function. I have to explain this assert macros also for sake of the person that asked. So I'd have loved for somebody just to explain this, but then it's fine. So the way this works, so two three is going to give us an error, right? Because 2 is less than what 3. And we're keeping our function as simple as possible. So I'm just going to keep this like this 4 3. So we know 4 minus 3 is going to give us what? 1, right? Can you hear me? All right. Can you hear me? I want to show that. So yeah. Our function is going to be testing that this returns a Boolean value, right? So I'm going to be testing that this returns a Boolean value, and the Boolean value we're expecting right now is a true. We're expecting true because this is supposed to give us 1. 4 minus 3 is supposed to give us 1. And if not, sorry, if not, we're going to be returning an error, right? And what was our error? Result not 1. Simple error. So that's for the assert function, right? I wrote this comment to make it easier to understand. So the assert function, the way it works, right? It takes a Boolean value and an error, right? And if this Boolean value happens to be false, it's going to return the error. The error is going to be in the output. So if this Boolean value is true, it's not going to return the error. That's how it works. But then for the assert LT, takes a first value and a second value and then an error. And what it's going to do, it's going to ensure that the first value is less than what second value. I wrote assert LT, right? Less than. So now we can call our function to give us a value, let's say 10, 6, which is supposed to be 4, right? But in this case now we are not comparing it. In this case we add a compare it to ensure it's 1. But in this case we are not doing any of that. we're just going to pass in this function, which is going to return a value, right? Going to return a value of 4, and then we are returning the second value, which we want to be less than. So we want it to first value dot less than second value. That's what we want. So we know this test is going to do what? It's going to give us, or this sub function is going to give us what? 4, right? So we can write the second value, which you want to be. Is anybody following? I write the second value after writing the first value. So 10, 6. I write the second value to be 5. Knowing that 10 minus 6 is 4, 4 is less than 5. So the test is supposed to pass. If not, result is not less than 5. So now with these error messages, we can easily point out to the test that fails. Right? Knowing the error message, we can find out what particular test failed. Who asked the question about Assert again? I hope you now quite understand how it works. So if it's something for Assert QT and Assert EQ. Yeah, the person that asked the question, I'm not seeing down. Alright, so that's basically how it works. Assert EQ also takes 2 values, right, and then the error. But just only the assert that takes the boolean and then does that. So that's that about our little test, right? And if you notice one other thing is that the fact that we wrote all of this in our lib.cairo, right? We wrote all these codes in our lib.cairo. So which is our main entry point to the application. Our main function is still empty. If you look at this, our main function is still very empty. Okay, we actually even put the add function, right? We actually put the add function, but then our main function is empty. Let's write a few more tests, then fix that and run our tests to ensure that our test pass, right? So yeah, one more test. Can go ahead to write the other test. For this particular test now, I'm going to be exploring what I was explaining to you about writing tests that you know would fail. Right? So writing positive and negative tests. So writing tests that we know are supposed to pass. So I'm going to write tests that we know are supposed to fail. And so I'm going to be starting with the multiply function. So test multiply. Oh yeah, I write test multiply, then I write another function to test. Another time I have it, then it shouldn't be a complex thing. I believe everybody understand what's going on here. More pass the first value 3, 3, 9. So you can just run a simple comparison, and if not, and please guys, make sure I'm not making any mistake. Alright, notice. Alright, I can't. I just see one mistake. And nobody has reminded me. So it's not a big mistake, but then I named my function mole, right? So my test, if I'm following the convention, it's going to be test mole, not test mole. Nobody observed that. Result is not 9. I'm explicitly putting all the values. You can name your test whatever you wish and your errors. So yeah, use a simple test to test the multiply function. Then I'm going to write another test. I was talking about writing tests that fail. That test is also going to pass. Now I'm going to write it. So, but I just want to use the standard naming conventions that you've seen in a lot of lot of test scenarios. You usually start with tests if you're testing a particular function, right? The name of the function, and then if you're testing the scenarios where the test you fail, you see something like test add should fail, right? Something like this. Then anybody see? So yeah. And there is another macro we're going to be adding to this function, right? How was that? It is the should panic macro, right? These are it's written. It's basically just tells the compiler that this contract is meant to panic with a particular panic data. All right. Tells the contract that this is supposed to panic with a particular panic data. I'm giving you the syntax for this. So yes, the panic data is going to be gotten from our Assert. So if you observe this, when this fails, it's supposed to return result is not less than 5, right? So if this contract, if this test is going to fail, it's going to be returning what panic data. It's going to be returning results is not less than 5 as the panic data. So I'm going to write a test that should fail, right? We're going to be writing a test that should fail, and I'm going to be writing the panic data and expected. Right now, there's nothing expected, right? That I giving the error. I just put that, just bypass the error. But that's now your test should be, right? So I'm going to write a simple test for the add function. All right. And I'm going to be adding 2 values and giving it a wrong result. 4, 4. Right. Let me use the Assert Q for this. 4, 6. 4 plus 4 should not give us 6. 4 plus 4 give us 6, then you know there's a problem with our code, right? So Assert 4 plus 4 to give us 6. And we should result is not equal to it's just a panic with this. All right. Then almost test on the div function. But this is writing a test that should fail. Right, so to do that, we're going to be adding the macro to panic expected. And then function test div should panic when graduate anybody there? So I'm going to sleep already. Graduate by 0. So div function, right? Our passing 2 arguments, then comma 0. 10 divided by 0 is supposed to give us an error. I'm not returning this as a value, I'm not returning the value, I'm calling this function. Yeah, so test, this is everything. I was in the talking test, this is right. So quickly we can try to run this test, see what's the progress so far. And I keep it, I hope that you can do that. I use this to control, but you can do that right to view. I screen is so large as possible that to take that. That's what I just want to view terminal because of the width of my screen otherwise. So you can also run commands and you can now automatically. So I'll open the first test directory. So if you look at our Scarb.com file, you can see what test runner is there. You can see it's using the Cairo test. So you can see all the tests are just saying it's running the test. Let's look at test pass. So back passes. Right. Everybody see there? Any questions? Anything at all? Anybody else following along? I think yes, can you encounter any? So yeah, 3 tests passed, 2 failed. Now it's left us to find out why. Can you see my screen? Can you see the test? So if you can see this test, you can see test multiply function passed. Where is it? Okay, this function is passed. Then the next test you have test panic when divided by 0 failed. Oh, and here's the reason why it failed, right? If you look at our expected is what you can say. I expected is empty, just an empty string. That should not be right. But I forgot to put the panic data. Right? So that's what I was talking about panic data. So also not just testing your tests to make sure they fail. They have to fail with a particular panic data, right? So your test can fail for a different reason, right? That is not, and that is, let me explain it using the scenario here. So now we expect this test to fail, right? Expect this test to fail for what reason? For the panic, because we're dividing by 0, right? But now this test is failing. Our test that we expect to fail, right, is failing. It's different for different reasons. Why? Because we do not put a expected panic tweet. You can read what is written here. You can see the failures. The 2 tests that failed are written under failures. And you can see tests give should panic when divided by panic with this. This is an X value, and then this is the value in string division by 0. And then you can see another panic with assertion. This is failed. Rest is not equal to 0. We'll go back to that later. Let's fix this first. So now, division by 0, right? So this is panic data that we're expecting. We know it's supposed to panic, and it's supposed to panic with this, with that data. So when it doesn't panic with that data, then something is wrong. So we can run the test again, and we expect the test to pass, because now we are testing it to fail, right? And it sounds kind of funny. We're testing it to fail, right, and pass, and it's going to pass if we are deciding that, okay, let me explain this very easy. You are deciding that this test is going to fail, and if this test does not fail, then there's an error. All right. So, but if this test fails, then that means the test is working properly, and then it's gradually should okay when the test fails properly. Do you understand how the should fail works? Do you understand what I just explained? Nobody understands. I'll explain again. All right. So we're writing different tests. This test will fail. This test will fail if there's something wrong anywhere in the code, and if it's failing with this panel data, right? That's what it's failing. But then in this test, because of this should panic, we are we are already aware of the event in which this test fails, right? We are aware of this. Okay, yeah, right. Focusing on this, yes, not this. So we're already aware of the event in which this test fails, and it's supposed to fail with this particular panel data shown by 0. So if it doesn't fail with this panic data, then our test is wrong. Right? So for our test to be correct, that to fail with that exact panic data. I will run our test for the second time. Panic with shown by 0. That's make sure this is what it is. Are you following? I'm running the test again to make sure that it panics with the expected output. So now you can see I changed this from a failed from the binary with double string to a failed. Right? Now I can see the single string there. Now there are 4 pass tests and 1 failed test. So you know that I'm not getting any reaction. If you have questions, ask your question. Why you don't understand. I have to make sure people are following. So you have wrapped the on your end that it works.
Boss, please. I don't know. Can you go back to your code, to your code editor?
Yeah.
Okay. This part, this should panic. My network tonight is really weird. I mean, and so it makes me I do miss some information you're passing. So this should panic. Just explain this place better. From should panic expected.
So can anybody explain this? I don't see if anybody can explain this. Can anybody explain that should panic? Nobody can. Let me go through all you have left. So I have to explain that again. So the way this should panic works, right? It's telling compiler that okay, we expect each case to panic with this particular panic data. Right? This division by 0 is called the panic data. It's panicking with this result, right? So we run this test, right? And because you're dividing by the compiler is going to give an error when you divide by 0. So we want to make sure that the compiler gives that error, right? So we don't want to be caught off guard. We don't want to be caught by an error that we are not aware of. That's why I was thinking before that when you're writing a test, you write test for the positive result and the negative result. So now we're writing test for the negative result, expecting the test to panic, right? Did you understand? Who has the question? Coordinating STRK. Who has the question?
I have a question. Okay. I thought that should panic would be used for situations where the compiler would really panic, but I see that it is used up there. No, the first should panic. There is no reason for a panic of the compiler up there in where you says result is not equal to 8.
Yeah, we're going to go back to that. I wanted to explain this first. I wanted to explain this first. I wanted to make sure you understood this. So the person that asked the question, let me believe you understand this. So yeah, we can take this out. Yeah. What was that? What was trying to speak?
See, I would just like, God, network. Very,
I can
very
hear you
bad
clearly.
tonight.
I can hear you clearly.
I would just go back to recap when it's being uploaded, and I would just take my time to watch this part very well to understand, because my network keeps my network keeps sending me out and logging me back in, so I'm not consistent. So I'll just go back to the recap when it's being posted in the YouTube and watch that part very well.
David, your hand is raised. David.
Yeah. Yes, sir. Can you hear me?
Yeah, I can hear you.
All right. I'm just a little bit curious. How would the division logic work when dealing with undefined numbers? I'm not sure what I mean.
I didn't get what you said.
What would be the result if we work with undefined numbers? Just curious a little bit, like 0 divided by 10.
0 divided by
10.
So I can that also. Around this. You know this test you feel. So we can remove that. We can remove that should fail because it's not panicking. They run the test. And you know the test now is going to fail because it's. Can you hear me? Alright, so I'm running the test with 0 and 10. Can you see this? Two tests are failed. Expected panic, but finished what successful. So also in case we fail, our tests do not panic, and we have explicitly written in the test that we should panic. That it's going to cause our test to fail when we run our test. So doing 0 divided by 10, right, is not going to panic the compiler. Right, it's not going to panic the compiler. So that's why it is our test is not failing. Right. So and because our test is not panicking, so that's why it's failing. That particular test is failing. Do you understand that?
More or less to an extent, but
Yeah.
yeah, I get it, but it is all cool though. I'll figure it out.
You don't?
I'll figure it out, don't worry. It's fine.
I really cannot hear you that much.
I said I'll figure it out. I'm trying to understand, but we're fine.
That's what I'm trying to explain to you. That's my job here to explain to you. Right. So now 0 divided by 10 is not panicking the compiler. And the compiler will not panic. The compiler is going to compile it successfully. And it's going to compile that successfully without panicking. That's why the test is failed. Right.
It
So
was If it was a
Yeah.
regular function, what would be its output? Like if we do 10 divided by 2, we know the output is going to be 5. Or if we do 0 divided by 10 or 0 divided by 20 or anything like that, what is going to be the output?
I think that should be 0.
Yeah, the output should be 0. Why should it be an
that's
undefined number? I
simple
don't think
math.
so.
That's math. If you do that in your calculator, also 0 divided by 10 should give you 0. But 10 divided by 0, dividing the number by 0 is supposed to give you supposed to panic, right? You're not supposed to be, right? So that's why it's panicking. You understand that? So he's not, he doesn't have to do something special about this should panic. It's about the logic, the mass of 10 0 divided by 10. Just works. 0, right? So Abstraction, this field and results is not equal to 0. Alright, so now if we look at this, we're coming back to this function here, right? Are we still following? I need a thumbs up, anything. If we look at this function here, look at this function, we are using the Assert STRK, right? And writing the field that is meant to field, right? But then it's panicking with another panic data, right? That's what I was telling you about panic data. If you look at this, it's panicking with another panic data, assertion, this. Let me run the test again. So this test passed 10 divided by 0. So we'll be left to just like this. Because it did 0 divided by 10, that's why the test was failing. So now this test is failing as it should. But then our should panic that we put before, right, was panicking with the wrong data. Panicking with the wrong panic data. Look at this. I'm going to tell you the panic data that panic assertion. This is not equal to this. Alright. This is I don't know we're using Assert STRK. So yeah. And in the recent, if we copy this panic data and put it in our should panic, I believe the test is going to pass because it's going to panic with that panic data. Let's try that out. Though the panic data is kind of long, so you probably use the simple Assert. Let's try that. Let's put this in terminal. What are we seeing? It's a long. Well, I've worked something like this before. But then let's try to use, instead of Assert STRK, let's use the Assert macro. Do this. Let's see the panic data. Once we learn from the panic data, which is compared to this. Then we actually run out of time. Let's write the counter contract. But then I'll need you guys to do that for me, right? A simple counter contract. Let's write a simple counter contract that increases the counter and decreases the counter. I believe everybody knows how to write a smart contract, right? So that's what you're going to be doing as your assignment for this session. So everybody's going to write a simple counter contract that increase the counter with smart contract in storage and decrease the counter. You can add other functions that you feel should be there, and then we work with that. Right. So whichever contract you write, whichever smart counter contract you write on Wednesday, right? Wednesday is going to be our next session. We're going to test that. I'm going to teach you how to test the smart contracts that we've written, right? Using the basic functions that I'm actually to implement. So that also test what we've learned about writing contract. So now coming back to this, we can see it's panicking with a new panic data, right? I was talking about that panic data being too long because we're using Assert EQ, right? So now we're seeing a new panic data not equal to what it. You understand what just happened right now? I don't think you understood. So it's panicking with whatever the pass here is the panic data. This is the panic data. According to our asserts, right? Suppose asserts that this is going to be a Boolean value, right? Which is add 4 plus 4, it's supposed to be 8, it is supposed to be equal to 6, right? And that's supposed to give us a false, because 8 cannot be equal to 6. And since this is a false, it's going to panic with this assert. It's going to panic with this error. You understand that? I explained that before. So, but because we're using the assert EQ macro, right? That's why it was giving us that quite long explanation of the panic data, right? Which we could not just put in our should panic, right? You understand what I'm trying to explain right now? So the assert EQ was because of we're using the assert EQ. I think panic data is still here. So that's why it's giving this. It's trying to give more information. Why? Because we're asserting that this must be equal to this. So it's giving all this information, assertion of the first value you're asserting, right? Fields, because this is not this has a lot of this, but we could just easily use the assert macro, and since we're checking for the equality, we can use the comparator to make sure that it's a Boolean value, and then as we get our what do you call it, our panic data as seriously not equal to 8. Right. So now we can write our should panic. I believe we should panic with the correct panic data. Yes. We will get just tell that our community name is mistake. Let's take that on all that process. So those are the basic tests we've written. Mainly what I've explained to you, I've explained to you how to use Assert to test the output of your smart contract. There are still other ways you can use to test your smart contract. And then one more thing, I'm going to show you one more thing. Looking now, if you can see that all the tests are passing right now. Right? They have 5 parts, 0 field, 0 ignored, 0 filtered out. Does anybody understands this? Anybody? I need some response right now, interaction. So you can see that all the tests pass right now, right? And that's because we're passing in the correct panic data. So if we get the panic data wrong, the test is not going to pass, even though we are telling it that it should panic. So we need to get the panic data right for our test to pass. So I believe I've been able to explain by the errors and every single thing I've gone through together. We sailed and we won, and all our tests are passing. So yeah, when you're building your contract, your code base, you have to make sure that when you write this test, the test pass. Based on the coverage of the test or how much test you can write, determines how much secure your code base can be. If you just test only one part, there are a whole lot of other parts that are left to be more vulnerable. So the more coverage you can, the more tests you can right? Like the more use cases you can test, if add should fail when you put a very long number, and all those, there are different scenarios we can test, right? So all those scenarios that we test help us to understand where the vulnerability is most likely going to come in. So I think I've explained a lot about writing basic unit tests, right? And if you remember, I was talking about unit tests. So this is an example of a unit test. We're testing these functions individually, right? And one more thing I said about unit tests, we can write them right in the same file as the functions. What we just have to do is write this configuration macro, right? I create a module called tests, and then write for each test I need to write a test macro and write the test function. Right? I think I'll be able to explain all of that. I don't know if there's anything I'm missing. Okay, I said I was going to show you something that you could be very useful. Right? And that's the ignore macro. Ignore macro, if I need ignore macro to like ignore a particular test. I will not advise you to ignore your test. I will advise you to make sure all your tests are passing. When you want to ignore a particular test, you can do that easily with ignore macro. Under the test, you can just write ignore. And you can see there's 5 pass, 0 fields, 0 ignored. If you should run the test again, you are supposed to be seeing 4 pass, 0 field, and 1 ignored. That will be explanatory. So just adding this macro, the compiler knows, okay, I'm ignoring this and moves on to the next test. So you can see this showing ignored, and then this test. But then one more thing to observe, you can see this gas usage, right? So gas is a unit, right, that measures the quantity of, what I call it, of, let me just say power, or there's a word for it, I don't know where it's not coming, that has been used, right, to do this, the computation, the amount of computation, I think that's a good word, that has been used to execute that function, or that function. So the amount of computation, so I'm leaving my phone now. So you can see the estimated gas usage for this function is about 1950. This took a lot more gas than the previous, and it's just 600 gas. So you can also specify the amount of gas you want to give a particular function. Like you can limit the amount of gas you want a particular function to give. And it can be very useful when you want to prevent a function from looping continually, right? From like infinite loops. And like you can like specify the amount of computation power or amount of gas you want function to take. So yeah, let me just try out with one function, one simple function. Can I get to my screen? Right. So yeah, back here. If you can see the gas for this is 1950, right? If you put a lesser gas, right? Let's say this takes 1950 gas. If you put like 100 gas, which is quite very low, function is going to, right? But how about right a new function? Yeah, let's see that do that. But how about write a new function called power? Right, this is like a function for raising to the power, for exponential or exponent. Yeah, function for exponent. So writing the logic for the function and a simple function that uses a loop. This is a more better scenario where you really want to like optimize the amount of gas that is used. So x is a U64, y is a U64, right? Then it's supposed to return a U64. That's the race part. So taking this is going to be so x is going to be like the value and y is going to be like the power that is using to the experience. So that our function is going to work. So basically how the function is going to work, I'm going to create a mutable array. I said array, a mutable variable, right? A variable that we can change with the mute keyword and can just give a starting value of 0. This is going to be like our counter, right? That's going to count. So the counter is going to count, going to continue looping until the counter matches the exponent. So once the counter is equal to the exponent, we're going to stop multiplying by itself. Alright, so counter as counter the value, right? We have the value which is the U64. I'm going to start with 1. Right. So why are we starting with 1? X raised to power 1, right, is 1. X raised to power 2 is x times x, right? X raised to power 3 is x times x. So yeah. Now we retain the variables that are going to be using. I don't know why my system keeps zooming off and coming back on. So the result is going to be a simple loop, right? A U64, let's add the character for this. It's going to be a loop. I'm going to loop through and increment or multiply the value, right? Multiply the value until the counter matches the exponent. So if I, which is our counter, if the counter is ever equal to the exponent, which is y, right? We want to just break. And we're not just break, we want to break. If we just put the break keyword, it will just break the loop completely. They want to return the result, so we can pass the result back to the function. So we're going to be breaking with a value, right? And that will be the value keyword that we created, right? Breaking with the value keyword. So if the counter is equal to the exponent of breaking, and we're just returning the value. Else, if not, I'm going to multiply the value by the, what do you call it, by the initial value. I don't know if naming this value is quite alright. Exponent. And then x. I actually name my x times the value. if the initial value was x, right? If we're following, so if the initial value, if the counter is not equal to the exponent, we want to keep on multiplying the exponent, which starts with 1 with the value. So it starts like 3 times 1. If the value is 1, then 3 times 2 increases. So then what we're going to do also, we're going to increase the, I don't know if I'm making any mistake, you guys should please alert it. I think we're running out of time. 10:42, okay. Some of you guys came late, so leave us to follow. So increment the counter.
Yeah, question. We don't have a simple math, I don't know, function that we can import to take care of that exponential.
Okay, in this case, I'm trying to like write the function just for the fun of it, right? Do you understand?
Yeah, I understand, but for what reason?
No, so we can test it. So we can test it knowing that we wrote this function ourselves. It's not tested already. Right.
Okay.
We have our function. Good to go. Are we good to go? So now this function uses a loop. Let me just go through the function again. It uses a counter and this checked experiment. Alright. So the value is exponent, which is what is going to be returned. What this does, it literally just assigns this x times x back. Right, so the shorter way to write this, so it multiplies the exponent times the value and takes that variable and updates the x variable back to itself. So the shorter way to write this is back to center. So yeah, I think our function is good. So now we're going to write test for that really quickly. I'll make sure that test is passing. So we can call it a night. So the function test exponent, right? All the name the function x. And we forgot to import it, right? Using the super function. That's when it becomes exposed to this test module, right? Because it was created in the parent module. That's the so yeah. So now we're going to like try to do the exponent of a very large number. Right. Exponent of how large can I think? So let's see. Someone give me a very random number. 200 exponent of 399. Yeah, so this is going to raise 200 to the power of 299. Thank you, this accuracy. I'm going to give you a lot of gas for this. It is going to take a lot of complication to continue looping and looping and looping. All right. So now, can I specify the available gas that we want this function to use? Right, available gas. And then pass, let's see, 2 million. 50 million. Let's say 2 million. Okay, and Shavka is giving us an error because we did not put the semicolon at the end of this. Right, so Who doesn't understand how we got here? Let's see whether this is going to take a lot of computational power. Doesn't understand how we got here. Any question quickly? Try run the test and find out. Questions. So I'm running the test to find out if amount of gas that I specified is exceeded. So yeah, once the amount of gas is exceeded, it stops. It stops, it shows the place. As you can see, it shows U64 smooth overflow. Alright, the text experiment. Move over. Okay, times is filling with another data, filling with another panel data. Right. So the U64 is not able to carry that large amount of this of data. Yeah, that's what it's feeling. Right. So if you observe the way I'm doing it here, I'm looking at my panic data and using it to configure my tests. So the tests pass. So when it doesn't pass, I know, okay, it's failing due to some other reason. Do you understand? So let me try to like take this down a little bit. Let's see. That's unsigned together. And also we are using unsigned integers for this. But then if you observe something, this test is not testing anything. It's only checking, it's only giving an available gas. In a real life situation, you don't just want to test based on gas. You want to test based on an assertion or something. So we can still further edit our test. I don't know, should I just let this test run? So I edit the test. Not 5 pass. So yeah, you can see the test actually passed. And you can see the estimated gas is 22,540. Okay, that's not the test. Exponent. Okay, if this test is 1,590. If we do this, let's see. I will do this like 20,000, just 20,000. Let's see. And then I was saying something else about not just testing, not just writing a test based on gas. It's write a test that actually tests something in your code base, because now all this test does is just tests that the available gas is not exceeded. But then if you look at the panic data of this test, it's showing out of gas. Why? Because I reduced the gas to a very low amount, which was even below the amount of gas it's using previous time, 20,000. So like 20,000 gas is not enough gas to run this test. So I think I'll just put it back 200,000. I was talking about writing test that and the part of the so I can simply do this. Who knows what 2 is part of this? Anybody 2 is part of even mathematics knows what 2 is part of. Nobody should use your calculator. But then you can use your calculator, it's fine. getting everything. Do you want me to solve it? Because I want to assert that they are getting the correct. Right. Anybody? Are we saying something in the chat section? I'm not saying.
It's 4,096.
Exactly. 4,000. So we want to assert that this is equal to 4,096. Else we cannot pass up any data that says results is no, it's 4,096. Or yeah, it's just a simple panic data. But then it's not meant to panic, right? The way we look it's not meant to panic. So I need this test to pass. Now let's get it. Basically, we're using the right amount of gas, I believe. So you should not fail. Now you can see 5 pass, 0 failed, 1 ignored, and it's ignored because of this no macro that I have here. Alright. So any further questions or writing unit test? I want to go through any questions or writing unit tests. So I think I've explained so many things when writing unit tests. I'm using the Assert code. Anybody has done the same thing, try to replicate the results and is not getting them. I also like to explain for that before we come to an end of the class. And also, I give an assignment on writing a counter contract. Please do not forget to do that because that is what we're going to be doing in the next class. That's the first thing we're going to be doing in the next class. We're going to be testing the contract towards counter contract. Right, today we have tested a simple Cairo using the Cairo Web3. Any other question? Because it's quite late. Other questions? So since there are questions, let me just ask.
Question. But
Right.
the assignment that you gave it is to write a test for a smart contract, right?
No, you're not writing any test. You don't write any test. All you have to do is to write a counter contract. Counter contract. You write it in the chat section. Write a counter contract that increases or and decreases counter state contract state. So yeah, that's the assignment. It's simple thing. Yeah, and that should be done by the next class. So that's what we're going to be using for the test. Alright. So since there are no questions, I want to ask like 2 questions and then I'll let you guys go. So you can like differentiate between the Assert, right, and the Assert LT. Quickly, Assert and Assert LT. Try start calling names. There are couples people on this call. Can differentiate between Assert and Assert LT. Can you hear me? Maybe I'm not audible enough.
I think you are. It's just that it's not. Okay, Assert. Let me try.
All right.
Assert is the keyword, whatever, in the language to test for a specific condition. It could
Yeah.
be equality, it could be Boolean or anything else. Okay, now assert LT, I think it's LT stands for less than.
Yes, it is.
It is to check whether the first value is less than the second value.
Exactly.
That's what I understand.
Well, thank you so much. Yeah, like my best student right here. I don't know, the others are just playing around. Yeah. So that's basically how it works. The assert just tests for a Boolean value, and the assert else tests for a value being less than another. And then one more question, and then call it a day. It is the question on should panic, right? When do we should panic? Like, when do we should panic?
Mm. Can I go again?
Yeah. Nobody
Okay.
else wants to answer.
Okay. I leave Shioma.
Choma, yeah. I think we're on the same page. I mentioned Choma, you also mentioned Choma. We're waiting. Choma, you did. I think he's not responding. Ademola. Ademola is also not responding. The next class, I'm waiting for you guys. But then, let me just explain it myself. So you should panic when you're trying to write a test that you are certain that would give an error in the compiler, all right? And you should panic with an expected panic data, like you should panic with a particular result, right? So if it doesn't panic with a particular result, then there's an error in the code, right? That's how we use the should panic. It basically just tells the compiler that this code should always um panic, and if it doesn't panic, then there's something wrong, because I explained something about writing the positive tests and the negative tests. I think that's like the easiest way to like explain that should panic and writing tests. Right. I think if that's I've come to the end of today's class.
Question about this should panic. So there are
Yeah.
two cases. You can use should panic in two cases, right? Where it should really panic. It should the compiler should get an error. And the second case is when you expect I don't know, a
Yeah.
result that is not exactly correct.
Yes. Yes,
Okay, all
that's correct. So when the compiler should give an error, you can use should panic. And when you're asserting for something, right? You're asserting for something that you expect to work in a specific way, like this, right? You're asserting that this should do this. Else, we're going to make it panic ourselves with this error, all right? So asserting this, and if this doesn't come true, you can panic something, right? Can panic with the panic data ourselves, right? And then knowing that this is gonna fail, our panic is always gonna come true, and then you can use this with panic to ensure that this always fails, right?
Okay, yeah.
Yeah, that's really explanation. So yeah, always make sure to go through the Cairo book. There's a lot more information that I can get here, and that'll be all for this night. So no further questions, right?
Not for today. Next time.
Yeah. So thank you for staying with me, and thank you for your time. Have a good night. Have a good rest. Enjoy the rest of the day.
Thank you, GN. Good night.
Yeah, I just hope you understood what was taught. So yeah, see you guys.
All right, thanks. Bye bye.
Yeah.